Hi all, welcome to my channel Simple Concepts by DJ. Today we are going to see about capacitor. Okay, the heading is parallel plate capacitor. The heading is parallel plate capacitor. Parallel plate capacitor. So in this parallel plate capacitor, you have two plates. So in between the two plates, there will be dielectric medium that will be filled. Okay. So for example, here in this condition is we are seeing that the dielectric medium will be uniform dielectric medium. This is uniform dielectric medium. See, for this we are considering two plates. Here one plate is called as M and other plate is called as N, and let us assume this N plate is connected to the ground terminal. This is connected to the ground terminal. Let us assume this is a capacitor. The capacitor consists of two plates. That is, one is M and other one is N. So I am giving a potential. Voltage is given. So this M plate acquires a positive charge plus Q. Okay. So this negative N plate will be acquiring a negative charge over here. Let us assume the dielectric medium that has been filled in between the gap between M and N plate B epsilon r, that is the relative permeability of the dielectric medium that is being filled in between the plates M and N. Okay, so this is epsilon r. So first thing what we need to do, when I apply a charge, when I apply a voltage here, what will happen? A flux will be flowing. Okay, flux will be passing through this dielectric medium. For that I am indicating the flux. Okay, that is the flux as flux equal to, it is being denoted by the Greek letter psi. Let us assume, because I am applying a voltage here, when a voltage is being applied, flux keeps start moving into the dielectric medium. So when the flux keeps moving into the dielectric medium, there won't be only one flux that will be moving. There will be a combination of flux that keeps moving here, because the potential that I have developed has a higher magnitude. So the flux also will be multiplying, and there will be a group of flux will be crossing this dielectric medium. So flux is equal to phi. So as a group of flux keeps moving into the dielectric medium, the volume of the flux will be more. So that is expressed as the flux density. Okay, I am expressing it with flux density. So there will be some density for the flux which is entering into this dielectric medium, right? So flux density is being denoted by capital D. It is denoted by capital D. So this capital D is nothing but, flux density is nothing but flux divided by the area in which it travels. Okay, so that is nothing but phi, that is the flux divided by the area. Let us assume that capital A be the area of cross section. So this is flux density is the ratio between the flux and the area. So this flux, okay, this flux is being caused by the potential. It's been caused by the charge plus Q. This plus Q is responsible for producing this flux. Plus Q charge is responsible for producing this flux. Without the charge, the flux wouldn't have developed. So this flux can be equated, will be equal to this plus Q. So I am putting flux psi is equal to plus Q divided by capital A. The unit will be coulombs per meter squared or square meter or whatever it is. Okay, this is the unit. The unit for charge is coulomb, unit for area is meter squared. So this is Q plus Q divided by A. So this is all about flux density. So now we need to find the electric field intensity. Okay, because when I apply a voltage, the voltage will not be unity, it won't be in a single form, the voltage keeps multiplying. Okay, so I'll be having the intensity of the electric field will be more. So electric field intensity electric field intensity will be electric field intensity. This is a denoted by the letter capital E. Capital E is nothing but the ratio between the voltage that has been applied and the distance. Let us assume the distance between from this plate to this plate be small d. I am representing the distance between the two plates M and N as small d. So the electric field intensity is nothing but the ratio between the voltage that has been applied across the capacitor and the distance in which the two plates are set apart. So this E equal to capital V divided by D. E equal to V divided by D. Okay. So now there is a relation in which I can equate the flux density and the electric field intensity. So that is nothing but D is nothing but the flux density, that will be equal to epsilon. Okay, this is called as permittivity into this electric field, which is electric field intensity, which is E. So D equal to epsilon into E. So this is the relation which links flux density as well as electric field intensity. So D equal to E epsilon into E. So now what I'm going to do, I'm substituting the value of D over here. That is Q divided by A. Q divided by A is equal to epsilon into the value of E will be V divided by small d. So now I know that the Q equal to C into V. So C will be Q divided by V. So I want to find the capacitance. So the ratio Q by V I am interested to find. So I have Q and V. So I am making it to be a ratio Q divided by V, which is nothing but the capacitance C. So this Q by V is nothing but epsilon into A divided by D farads. D farads. Okay. This is the expression. So now what I'm going to do is C. Now C will be equal to epsilon can be split as epsilon naught into epsilon R into A divided by small d. This applies for any medium, for any medium, for any medium other than air. Okay, so if you have the dielectric medium as air, if it is for air, AIR, the value of capacitance will be C equal to epsilon naught into A divided by D. Why means here for air epsilon R will be equal to 1 for air. So since for air epsilon R, that is the relative permeability is 1, I am getting this value. So epsilon R will be 1. So C is equal to epsilon naught into A divided by D. This is the value of capacitance when air is used as the medium here. So this is all about this uniform dielectric medium. If the dielectric medium is uniform, this is the value I'll be getting. So now, so this is the basic thing for uniform dielectric medium, right? Thank you all for watching this video. I hope this video will be very helpful to you. Thank you. Off பண்ணு, off பண்ணு. Cut பண்ணு.